Hello everyone and welcome to the Java implementation of the valid number problem from LeetCode.com. We saw the JavaScript solution in the previous video along with the whiteboard view and explanation of the algorithm. I encourage you guys to watch that video if you have not already and you have a little bit of time. But let's jump right into the Java implementation of the valid number problem. So as you can see, most of the pattern of how we solve this problem remains the same, just some Java syntax type of things that we have to include here. So for example, you see that we have constants that we've declared, the whole static final pattern thing. These are all constants in the Java language, and all of them represent the regular expressions that we described in the JavaScript solution video. All of these different patterns represent the type of numbers that we think we're going to encounter at some point in our input. Here is the isNumber method. It looks very similar, but there is some slight differences. As you can see, there are two for loops here instead of one from the JavaScript solution. And the reason for that is that Java does regular expressions a little bit differently. We have to sort of create these patterns, which are pretty self-explanatory, the actual regex pattern that we want, and we have to sort of compile them. And then what we have to do is create these matchers, which will then be used to test our input against the compiled regular expression. So that's what this for loop is doing here. The second for loop looks almost identical to the JavaScript solution, where we're just taking each matcher and matching it against the input. The input's already been sort of added when we created the matcher, so you see the difference here is that when we run the matches method of the matcher, there's no input being added because it's already been added previously. But the important thing here is that it returns true when we find a match. And if we go through all of our regular expressions, or all of our matchers in this case, we see that we're going to return a false value, indicating that we have an invalid number. Now, in our main method here, you'll see some input that looks very similar to the problem description and what we saw in the JavaScript implementation video. Some of these inputs are invalid inputs that I found through testing on LeetCode, and I thought it would be a good idea to add them here. So we have a group of valid numbers and a group of invalid numbers, and what we're going to do is we're going to cycle through or iterate through all of these valid numbers and use them as input for our isNumber function or isNumber method, and then we're going to print out the results. So I think at this point we're ready to go ahead and run the code and see what happens. So let's go ahead and do that in IntelliJ right now. And let's scroll up, and as you can see, all the valid numbers come back as true, very similar to the JavaScript implementation. All of the invalid numbers come back as false, similar to the JavaScript implementation as well. So at this point, let's go ahead and go to LeetCode and see what we get there. Okay, so taking a look at our code in the LeetCode view, we see that it's the same exact code minus all the tests that we saw in the IntelliJ view. And as I said in previous videos, we've just go ahead and run the very simplest test cases. So let's go ahead and see what happens when we submit this. Okay, LeetCode's processing everything. Okay. And here are our results. So the Java implementation of this problem, it gives us a score, a running time score of 24%, or just under 25%. It only beat 25% of the submitted cases. And for most folks, that's not very good performance, which leaves a lot to be desired, or a lot to improve on. Same with memory, not a very good score here. Just under 38% of beating only 38% or just under 38% of the submissions. So a lot of work to be done here with this solution, but it does work for the most part. In certain cases, like I said in the other video, in the previous video, the JavaScript implementation, there are going to be times that we run into very difficult problems, and some of our solutions may not necessarily perform better than solutions provided by others. But they are solutions nevertheless, and they do serve a point, a place for us to look at our code and find areas of improvement. If you see some areas of improvement or you have some suggestions, please feel free to leave them in the comments section. Please subscribe to this channel and get updates on any new videos that I provide. And also, if you have some time, take a look at the JavaScript implementation video as well as any other videos here on this channel. And thank you guys a lot. I hope that this code was a little helpful to you. Again, not the very best performing code, but hopefully it was helpful. And I will see you guys in the next video.